Howdy y'all, we're just going to go ahead and do a quick walkthrough of using my new tool, MFTAnalyzer. So just running it by itself will display this welcome message, just kind of pointing you to pass the -H flag to display a help menu. So if we go ahead and do that, I'm not going to go ahead and cover most of these commands, but you can see just as is, if you just give it an MFT file, it'll go ahead and parse the whole thing and display all the entries as table format. So to go ahead and give you guys an example of this, we'll just go ahead and pass this MFT file. It's a small MFT file, and we can see it gives us all of the tables in table, or all of the entries in table form. You can see each one starts with the file name and the MFT entry for it, with all of the different attribute tables below. So if I go ahead and clear and bring up that help page again, the current flags, you can search for an entry table based off of a file name. You can search for an entry table based off of an MFT number. But this tool's really most notable features are here with this shell command right here. What this shell command will do is it'll go ahead and it will rebuild the entire file system using the MFT number, giving you a couple of Unix-like commands to use on the file system. So let's go ahead and check that out. So if we run, or if we go ahead and pull up that MFT file that we were using again and pass --shell, this will open the shell for us. So in here, to actually go ahead and view the commands, if we just type help, we can see all the commands that we have available to us. So we can see there's obviously help to display the help menu. There's tree, which will recursively display the file structure of any directory passed. One thing to note is some of these commands are used with file names, while some of these commands are used with MFT entries, and there's a reason for that. So starting with tree, it'll go ahead and it will recursively display the file structure for any directory passed to it. If you just run it as is by itself, it'll go ahead and map out the whole file system for you. So let's go ahead and see what that looks like. So you can see if we run tree, we can see the whole file system. Now, like I said, this was a small MFT entry, and it was just used to test. Now let's go ahead and play with some of the other commands. So we can see we also have ls here. Note ls is also used with file names, and so we can go ahead and really ls any folder. So we can see we got a little bit of a structure going here beneath $extend. So if we ls $extend, we can see all of the folders inside there. Note we also have a folder here. It's right here. So if we ls that, ls folder, it'll show the contents inside that folder. Now, moving on from that, if we go ahead and clear the screen and bring up the help command again, we actually have a find command. So this find command, it's used with file names, and it was actually the inspiration for this whole project. I'll save that story for another time, but the way it works is you just go ahead and type find and then the name of any folder that you want to find. So let's go ahead and type hidden, and oh, great. So we can see hidden seems to be in /folder /hidden.xlsx. Perfect. We also have a cat function. Now note cat works with MFT numbers, and the other thing is rather than displaying the contents of a file with cat, it'll go ahead and display the entry table for that file. So if we go ahead and ls the root directory again, we can see all the files in there as well as their corresponding MFT entry numbers. So let's go ahead and cat the entry number for encrypted.txt. And this will display the table for it. So you can see showing MFT entry for file this. We have the entry header here, and then all of the attributes below it. Moving on from there, let's go ahead and talk about the hex dump command next, and then we'll circle back to carve. So hex dump, rather than cat showing you the nice pretty tables created for it, hex dump will give you the raw data for each MFT entry. Now hex dump, it is used with MFT numbers, And the reason why some of these commands are used with MFT numbers rather than file names is one, due to the processing, but two, due to the fact that these commands, it's not expected, or you wouldn't expect to have multiple files outputted here. Typically with these commands, you're targeting a single file. And because, obviously on systems, files can have the same name if they're in different directories, I chose to go with MFT numbers for these commands. So we went ahead and we catted 41. So let's go ahead and hex dump 41. Perfect. So we can see the hex dump of that file here. Awesome. Now let's go ahead and check out the carve command. So there's two things to note about the carve command. First, it works with not only non-resident files, but also resident files. Now, the other thing with that is obviously with non-resident files, we can't carve the file just from the MFT entry. And so the carve command is designed when run against a non-resident file to display the contents or the locations on disk where a potential analyst could go to carve said file. Now, with resident files, obviously, we can carve that from the MFT entry. And so, with the carve command, if it's a resident file, it will go ahead and carve it and save it to a directory called carved. And so that's where you'll find that. So let's go ahead and tree the file system. And we'll go ahead and we'll try to carve this text file in folder right here. Because this is specifically a resident file. So if we go carve 40, and we can see it first tells you where exactly the output is, and then it tells you how big the file is, what time you dumped it at, and then it'll show you actually the content of the file. And so we can see here I just put some sample evidence, file content, and this file should be resident, however I'm making it long. Where can I buy drugs? So it seems whoever was using this virtual machine or this system might have been looking for some things maybe they shouldn't have been looking for. Let's go ahead and move on now to a more real-world size MFT file. You know, an MFT file that has thousands and thousands and thousands of MFT entries. So we'll go ahead and run the shell command again, but this time we'll specify MFT copy 1. This is a much larger file I took from a Windows virtual machine that, well, had some bad stuff run on it. So let's go ahead and check that out. So you can see, depending on the size of the file, it'll warn you that the file is large and it may take some time to process. And there's actually a counter built into this so you can monitor the process of the tool, see if it stalls or hangs at all, and kind of just track the progress. So this MFT file we're using is just under 400,000 entries in it, and the tool has been very consistently processing this file right around 2 or so minutes. Compared to other GUI-based MFT explorers or browsers, those will probably run you about 25-35 minutes to parse the same file. So MFTAnalyzer is significantly faster than some of the GUI-based tools that are already out there. Now, this tool does not stack up against MFT ECMD. And the reason for that is because of the processing modules that go into rebuilding the file system and giving you all the commands here. Now, in the future, CSV and JSON output will be added. You might have noticed this tool only currently supports outputting to a text file. And so we'll see if we can clean up speeds once we get to there. But for now, processing the MFT entry in the shell mode will beat out all the other tools that allow you to do the same function much, much, much quicker. So we're going to go ahead and cut this out and come back once the tool finishes processing. Great. The MFTAnalyzer has finished processing everything. So if we go ahead and check out how we might use this tool in a real-world setting, let's start by just checking out what we have. So we can see it's a Windows system. I'm seeing regular things. Oh, look at this. What are these right here? These probably aren't supposed to be here. In fact, I'm seeing quite a few things down here that probably might not supposed to be here. So let's go ahead and examine some of those. Let's see what's in this temp one first. So let's go ahead and ls it. So we'll do 21023. Oh, excuse me. I meant to do ls temp. Cool. So we got a couple of things in here. Let's see what we got. I'm seeing some kind of d.txt. I wonder if this is resonant. Let's go ahead and check. So 21024. And nope, non-resident. So let's go ahead and go back to this. I'm seeing another text file. Let's check that file's residency. So 21028. So 8. And oh, I ran that with ls. I meant to do cat. So 8. And oh yeah, look at this. It is resident. Oh ho ho. That's interesting right there. Let's go ahead and look a little bit more at that. So let's carve that file out and see what those contents may be. So we'll do carve, and oh, look at this. This looks like it might be the output from a certain suspicious known malware. And we can go ahead and check that out here, so we can see the title or the name of the file must have been localhost. And let's go ahead and check that out. So, yep, seeing the same results here. Interesting. So, let's go ahead and ls the root directory again. How about the temp directory? Let's check that out. So, ls temp, and when I say this temp directory, I mean the one with an E. And I'm seeing files, a folder, another folder, and then some more files. This out.temp. Let's see if this is resident or not. So, and it is resident, but it looks like there's no file content. You know, this is the case sometimes, depending on what kinds of files you're working with. So we'll go ahead and go back to the temp directory. Well, let's try to get a bigger picture of it. So we'll run tree temp. Ooh. There's quite a lot in here. Oh my gosh, look at all this stuff I'm seeing. Cobalt Strike, C2 stuff. Yeah, this was definitely some bad stuff. An endgame directory. Whew. Alrighty, well, let's see, you know what? Let's go ahead and see if one of these executables is anywhere else on the system. So we see curl right here. Let's go ahead and check if curl is found anywhere else on the system, because this might tell us if certain files an attacker maybe used, maybe they put them in other places, or you know, maybe they found a way to achieve persistence with this file. Now obviously curl.exe, you can't do that stuff with curl, but that being said, it's just kind of an example for this. So we'll go ahead and do find curl.exe. Oh, and look at that. We got quite a few places where it's popping up. So, you know, we can take this and maybe with a disk image go start checking this out a little bit more. Obviously, like I said, it's just curl, and so it's not all that bad. But we can even see down here it's catching the prefetch file for it too. And so this is kind of telling us, okay, so this was run. Alrighty. That kind of concludes my little kind of feature show off and demo use of MFTAnalyzer. I hope you all find it useful. There's a download link to it in the description. It links you to my GitHub. And feel free to reach out with any questions you might have. If you notice any bugs, because this tool is in its first release state, there might have been some things that I missed. So feel free to go ahead and submit a GitHub issue, and that would be really, really helpful. Thank you all so much for checking out the tool, and have a good one. Bye-bye.